Actually, it's not too small. I can see quite well.
Okay. So
Yeah, this is perfect.
if you allow me to say C for customers, customer number,
Yeah.
arrive to shop or whatever. Okay. So we see. So normally when we say the number of the sales or customer, we say that way. But when we estimate, we made this head up. Okay.
I didn't know so. So the hat
Yeah.
means estimation.
Estimation, yes. So
Okay.
this is a start point. So I don't know how to make this estimation head
On the
just
C,
on the
sometimes
C here.
if you keep pressed the C, you can make a hat.
Okay, great.
Never mind. Never mind. If it doesn't work, it's fine.
Maybe it's gonna work here.
No. It's okay. I will know it's estimation.
Okay. So yeah, this is kind of like estimation.
Okay.
And you know, in general, what they do, business owners, they check their previous month's sales or customer things. Okay, then they estimate the next week. Next one is as a sales things like. So what I'm doing is I'm estimating using by previous. Then next month I'm thinking to get 70 customers.
Yeah. Okay, gotcha.
So kind of like.
All
If you
right.
allow me,
Yeah,
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 allow
yeah.
me this way. It is sale, 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 it is sale. Then next month is going to be same one with
But
this
one
red.
1 month
1
shifted.
month is estimation, yes. And you know you can do you know you can make it a bit complicated by doing estimation is you can take average of this okay, let's say for you want to estimate 10th month 10th time 10, let's say, okay, um, as a average of last 3 months.
Yes. Yeah. Okay.
So this is
Divided by
like
3.
average 3, yeah. So, but when you do that one, you need to check whether this estimation is. You need to check that one with the previous months, whether is
Uh-huh.
it valid or not. What does
Okay.
it mean? Like the last. So let's try that one. So difference between this and that is like discrepancy, and
2 points.
the 2.3 is your difference, and when we test in this formulation, okay, first one, let's say first one is the 3 time average of.
And then you get like a I think discrepancy, like the
Yeah,
standard, the deviation, isn't it?
yes, standard. Yeah, you can do. So we are trying to make it as little as possible because
Right.
we want to estimate as correlates as possible. Okay, so
Right.
therefore happening, and you know some of the
Okay.
formulations are exist. Some of the formulations are exist to check them. Is one of them is uh, MAPE. Okay.
So if I understand correctly, the goal is to create some models which will fit to the most precisely with the smallest deviation possible from the reality, basically.
Correct.
Yeah.
Yes,
Okay.
correct. Definitely. Mean absolute deviation. So one of the measure you can check that one is good or not, because let's say this one is the second formula. This is the second model. Okay, this is the first model, and the first model deviations are coming from here. Okay.
Yeah. Yes. Okay. And the second model is the average. Okay.
Second model is the last average things. Correct this.
Oh my God, I really, really like this kind of business stuff. This is really interesting.
I think you like mathematics, and so I think you can do some job in finance as well. But I don't know. You go with always different marketing and things. Anyway, so this is not our subject. This is like
Yeah.
it's called math. That one, okay.
Math. Okay.
Math.
Absolutely.
Formulation is hopefully is on the right here somewhere. If I can, because it's difficult to type.
Right.
A mathematical equation. Yeah, it is not there. Okay, then.
Mean absolute deviation equation. Where did this is? Okay.
I asked Copilot. It made me that formulation is
Yeah,
correct one.
this is more pretty.
Yeah. This is the formulation of like the absolute values of these needs to be sum and divided with the number of sample.
Okay. To be honest, Hakan, I can read that equation, but number of observations.
And
Okay. You might need to walk me through it.
yeah,
But that's just what we did, isn't it?
I didn't proceed that one. I just made this section.
All right. Yeah, the difference. Yeah. Okay.
Minus subtract. This bit is done only
Absolute
here.
deviation.
Here, subtraction.
Yes.
It means the subtraction is estimation. Can you say that head here? Can you see
Yes.
the head? Head estimation.
Yeah, I can see the hat. Yeah.
It seems, I need to do other way around the formulation, not this way. Let's make the correction. Let's
Sorry.
make it in book.
Other
Like
way around.
it is saying that, do that way.
Oh, so it would be positive instead of negative.
Yeah. But anyway, it is taking absolute value. You see that absolute?
Yeah. Oh, yeah. So it doesn't matter. Yeah, it's
Absolute,
just a
yeah.
deviation. Yeah. Okay.
Yeah. Later on, we are gonna have absolute of that one. Okay. Okay. Then absolute ABS, I think, isn't it? ABS. From data managing, probably you remember.
I don't remember, but I love Excel. I need to learn more.
So ABS is making the things positive, like if it is negative.
Yeah. Just absolute value. Yeah.
I add up that one as well.
Okay.
Then I'm going to make same things for them for here. ABS.
And see which model fits the best.
Yeah, more absolute deviation equation. Yes.
Mm.
So which is the less, it's going to be more favorable for us than when you're, for example, when you are manager in the future. You need to ask your staff if they do forecasting. You need to
Yeah.
ask them what's the mean absolute deviation. If you don't know how it works, you won't be able to. But
All right.
so which model have you used? What you did? So what is the difference between them? Can you show? So this is your then here is the we are gonna sum them and make them average. Just I want to make the count first because
Count. Oh, count.
count is how many. Okay, what is this? Ah, my missus is calling. Just bear with me. Okay.
No problem. No problem.
Efendim karıcığım.
Yep.
I'm back. Yes, the why count didn't work because I think the number of observations are here. That's therefore I want to do. And here is the number of observations, 5. Okay, they are going to divide it 5. So literally this is sigma symbol.
Yes, sigma is like the sum, isn't it?
Yeah. Then I'm going to make sum.
So if I understand correctly, is the sum from 1 to the number of observation
Yeah.
times 1 divided by the number of observations.
Yeah, divide, yes. Now this is the number of observation. These are. Then I'm going to divide them. Okay, is it okay?
Yeah, so it's basically the sum divided by the number of observations. So that's just average. Yeah, okay, I understand it now. The equation. That's just the average. Yeah, okay.
Average, yes. Yeah. This is the first formulation.
Yeah.
And can you say which one is better at the moment? This is the first one is 425. Other one is
Yeah. The second model seems to be better at the moment.
better. Yes.
Yeah.
You would like to go with that one, isn't it? And
Yeah, but originally, if I look just at the raw data, I would have said that first model was better, but apparently,
easy to apply that one, isn't it? Just check the
yeah.
recipe.
Yeah, it's interesting. So
So
this is the most used one, MAD.
yeah, most main in like small medium enterprise, they check last month's sales and they stock up their things accordingly.
Right.
Okay, let's make it the third one, okay? Third model. Again, I'm going to use mean absolute deviation, but I'm going to offer a little bit complicated one for this one. So I'm going to say the last, okay, these are, okay. Okay, it didn't come that way. Okay, I'm going to write from beginning because they are not fixed, therefore. So first one, so this is the third model now. If I say to you, let's make the estimation last month is weighted with 70%. Then the previous month is maybe 20%. Then one previous one is the 10%. So I'm just getting the weight of each month differently. So maybe you may wish to go that way.
But why would the 1 month have a weight different?
Last month, probably more recent, might affect your, yeah.
Okay. Okay. B6. Yeah. I understand that. That makes sense. Yeah. So the more you go in time, the more recent events are more likely to happen. But in reality, with the seasons, for example, in
Yeah.
month, it's not exactly like this, is it?
Yeah, it's not exactly that way it works, yes.
But it's interesting. Okay.
I don't know why I started here in the previous model. Yeah, all right, okay. I think I made this one wrong. Should go this way. Sorry.
Oh, no, that's okay.
I estimated things from the estimations.
Oh, right. Yeah.
So silly. Okay, sorry me. Silly me. Okay.
Yeah.
So it's
And
gonna that one is gonna make another calculation now. 3. Okay.
yeah, I think you need to paste also the formula uh below, isn't it?
Oh yes, correct.
Wow, it's actually really good.
Yeah, it's really near to 0 is good. Okay.
Yeah,
Then
okay.
let's make, because we have time and we are working full time somewhere and we need to check. We shouldn't jump to conclusion. We need to test, something
Right.
better we need
Right.
to reach.
Right.
And this is our task. This is what we get paid for. And
Okay.
yeah.
Please, Hakan, later give me access to this recording because this is really interesting.
Yeah. Okay. Thank you. Thank you. It's nice to hear from you this kind of feedback as well. Yes. Okay. This is 104. Why the next one is the same? I don't understand. Same. Okay.
Quick question.
Yeah.
This course will be if it's accepted or if you're accepted as a lecturer, which undergrad or master? Like
This is
who's
going to be normally this course is mainly given for the master classrooms
master.
in different universities, but we are going to include that one in the undergrad.
Undergrad. Okay.
But we
Because
are going to look after someone, attending this course is getting really good high in math skills.
right. Okay.
I can't teach Sigma like or something. So, they need to understand some mean, average, standard deviation
Right.
when
Yeah.
they
True.
come.
True. Yeah.
So we are expecting to see from a student coming from A level has got like a good statistical knowledge a little bit.
Right. I
Not
understand.
extensive, but good at least.
Yeah. Basic. Good basics. At the end of your explanation, maybe I can give some feedback about how
Yes,
how it
yes.
could be made interesting for undergraduates.
Yeah, it would be great. Yeah, correct. Yes. And
So this is
why?
the other model.
This is the third model now. Okay,
Yeah.
let's make that one. But I'm still improving the calculation. They are not working well somehow. Okay, this is the third one. This is the second one. This is the first one. So why they sum 309, 309? Okay, 6 is here as well. Why we have 6?
You wrote third model average of last three, but it's average of last 6, isn't it?
Actually, it's not average. This is weighted.
Oh, weighted average. Yeah. I forgot. Weighted average.
70,
70, 20, 10.
Yeah. You are so good student. Seriously, Nathan. I will always miss you.
Me too, I can. Me
Yeah.
too.
Okay. So yeah. So this is 319, and we are going to divide. So deviation is coming really big, it seems, but probably I made something wrong here. Right. Okay. Okay, that's why happening.
Wow, okay, this is interesting.
So, okay, no.
I think
But I
you forgot to
made it totally
divide.
wrong.
Yeah.
Oh, yeah, divide 3 is missed, isn't it? Yes, you are correct. Yes, divide 3. Then I'm gonna make here from beginning again. This estimation, isn't it? So the formulation was okay. Let it zoom out, then come back. Okay.
Yeah, x minus
Yes, correct. So
x.
x minus this one.
Wait, how do so it's subtracting from the original actual value each time?
Yeah, because we are testing this model with from past data.
Right. So yeah, you're trying to see the real value minus the estimate. What's the difference? Yeah, okay. Makes total sense. But
And
I cannot really understand why there's a deviation of 21. There must be a problem. This is like a big deviation.
yeah, we are gonna have a look that one. Correct. Yes, good point. 29. Deviation is huge, isn't it? Now it is estimating last 3 months by using this formulation.
Yep. Yeah.
Okay. This one. Okay, let's start from beginning. Last 3 weeks estimation. Okay,
Yep.
let me hide here because it's a bit far away. This estimation is last 3 weeks, 3 months or whatever estimation, and the deviation is 21.
Yeah.
Okay. Then this one is again last 3 months estimation. Deviation is 27. Okay, let's see this formulation is okay or not. Yes, correct. Yes, huge difference. Yeah, it's simply is too much.
How is it possible that the weighted average of 60, 54, and 58 gives an answer like so much smaller?
When we check here the yeah, I don't know how
Let
it
me
could work, but
let me calculate 60 times
okay, let's make it
0.7.
a bit bigger. Maybe my formulation. The last month is going to 0.70. Then previous month 0.20.
No, I
Then
think there is no divided by 3, Hakan. I told you divided by 3. There's no divided by 3 because you're taking like you want to make 100%, isn't it? So you're taking
yeah,
70, 20,
yeah,
10.
I made here 3.
I don't think it's divided by 3.
Okay, so I made them individually now. 0.70 is here.
Yeah.
0.20 is that one.
Yeah.
0.10 is here.
So you need to
Okay.
add them up together to get like the
Yeah, I add them up now. Then I'm gonna divide them one with 3.
Well, I don't think it's divided by 3, Hakan, because now you're making the average of 42, 10, and 5.8.
Yeah.
But this is not correct because this is not the average of 5.8, it's the average of 58. You know what I
Okay.
mean?
Divide 3. Okay, 19 should be 19, but it's not 19 here, isn't it? As you said. Okay. Why is happening? Because this formulation is wrong. Ah, okay, I got it now. I put plus instead times. Okay,
Okay. Here we go.
sorry.
Yeah.
Again, me.
So it was times. Yeah, but this is
Yeah.
even worse.
Oh, it's going to be fixed in a second, I think. Yes, somehow.
Okay.
It's worse. Okay. 19. Is it correct now? This one, first one. Okay, I'm gonna make them all of them one by one. I'm checking this column. This column, all of them correct. Okay. Then what we need to do, we need to make discrepancy between these two. And it's too big, yes. Yeah.
So, Hakan,
Hmm.
maybe you can try something else.
Okay.
So I think the weight needs to be, I think you shouldn't divide by 3. Oh, sorry.
Just this is everywhere. Okay.
I don't think should be divided by 3. I think it should be divided by the sum of the weight.
Hmm.
So the sum of the weight here is 1 because it's 0.7 plus 0.2 plus 0.1, so it's 1. So, but if you want to divide by the sum of the weight, you can put 7 instead of 0.7.
Yeah.
You can multiply by 7, then multiply by 2, and multiply by 1, and then divide the total by 10.
Now what I need to divide, I don't need to divide, isn't it now then?
Yeah, you don't need to divide by 3.
Because it's percentage. Yes, it makes sense. Yes. Well done, Nathan. Yes, you're great. Yeah.
Because I think that explains why there is such a big difference.
Yeah. Sorry. Then copy that one. Not copy. Okay. I'm gonna remove that divide 3.
Yeah, now it makes more sense. Yeah, here we go.
Now it makes sense.
Yeah,
It's
yeah,
coming to scalable point.
yeah, finally. Okay.
Height, okay. So 3.8. The third model is 3.8. It's better
Okay.
than first, but not the best.
Okay.
So you can carry on with this one.
Interesting.
Also we have another one. Is another sometimes okay. Let me find the formulation. Ramsey. Because I
Ramsey.
think you remember that one.
Maybe if you explain, I don't remember the name.
This is okay. I'm gonna write here at the top. Root. I don't want to make something wrong.
Root mean square error.
Yes, correct.
I'm reading online.
All right. Okay. I'm gonna bring that formulation as well. Okay. Here we go.
This could be included with OpenClaw to automatize the forecasting of small business and then display the results on a dashboard online so that they can see the curve like in real time.
This is great. Nice to see your interpretation is extending the business opportunities. So this one is tells how large your prediction errors on average. Okay. Giving more weighted to large errors because of the squaring and so kind of like, okay, I made some absolute only statistics I use absolute, but sometimes absolute is not great. So I'm gonna use a root square. Okay, let's say let's think that way. But if I say that, so mathematicians are generating so different formulation now. So that formulation is here.
So it's just a test. Instead of absolute, they test with I mean, it is a thing, isn't it?
It's kind of like, we are checking yeah, this kind of root square and So can you see this
2.
power? That
Yeah.
power make absolute, obviously,
Yeah.
if it is negative, but it is gonna improve, exaggerate the big differences.
Yeah, that's why they need to root square. Yeah.
Yeah, then they took reverse side. But this formulation is exaggerating the bigger differences. Okay,
Right.
so
All right.
this is the point.
Even if you root square, it still keeps the exaggeration.
Yes, because it's taking power
Ah.
first at the first point.
Right. So that's the point of it.
Yeah, that's the point. That's the difference of that one. Yes, correct.
So is the goal with this one is to really pinpoint if there is like an error? Okay, I understand.
And it is more tangible for statisticians. This one, they
Oh,
use me
interesting.
one. So what I'm gonna do, I'm not gonna write or change that one. Like I'm gonna make that one math here. Also make.
So if you can have a model with this which has 10 to 0, then it means that your model is really robust.
Yes. Yeah.
Mm.
If then, yeah, you can invest. You can arrange your workforce. You can arrange your stocks.
Mm.
It's really important.
Oh, that's
I
so
used to do these kind of things when I was doing my marketing things.
wow, that's so
See,
cool.
yeah, because I'm coming from engineering background,
Right.
therefore, anyway. So I'm gonna remove that absolutes because this is now new sheet. Okay,
Yep.
I'm gonna make them square.
Yeah, so you're just changing the absolute. Instead of absolute, you're putting square,
Oh, yes.
and then the total you're putting
It is becoming. It's gonna change at the in a second. It is sum. Yeah, but I'm gonna make that one is in a second. Let me finish that one first.
no problem.
Oh, it's a huge, isn't it? No.
But it's exaggerated by the square, you said.
Yeah,
So maybe that's why?
yeah, probably. Let me undo. What was the 44 is too much, isn't it? Yeah, it is the absolute. Yeah, it is exaggerating, isn't it? It's all of them becoming bigger, but this one didn't come so much big. So it seems that one is gonna be effective one.
Mm-hmm.
Seems, yeah. Okay, this is estimation. This is original. And this is square. Okay.
Mm-hmm.
So I find one of the error here. I just want to go back to this previous one, if you don't mind. Whether I made a mistake on this one or not. Yeah, should be that one. Even better, 1.94. Yeah, it make it a lot better. Okay, still same model is ideal at the moment, optimal, let's say. Okay, this is the round square one. Okay.
Yep.
Now we came up to here, this bit, this bit. We divide it with n,
Yep.
but we are gonna get the sub square of this value
Mm-hmm.
equals,
Sub square?
yeah, sub square
Square root?
CQR2, I think, isn't it? CQR2.
Oh yeah. Yeah. Cool.
So it seems
Third
The
model.
third one is seems nice at the moment.
Yeah, but so which it's
Which
it's
model? I would like to go with the third one now.
yeah, but why are the value like different? The ranking different from the previous equation.
Because the totally different model, isn't it? This model is wrong. The other one was this one.
Yeah, but the other one was even lower. I think it was 2.3 or something
Um,
from
but
the
in
math.
same norms, same scale, comparatively,
Yeah.
you need to check. Okay, maybe you can make this kind of evaluation. The first one is the second model. So then you can leave the last decision to your boss or your bigger
Right.
manager or whatever. Okay.
Yeah, yeah, yeah.
Second one,
And this one
ideal.
is third model.
Okay. So these are the things for estimation. Um, yeah. Sometimes we say if this one is okay, I'm going to next one at the moment. Okay, Nathan.
Yeah.
Is it okay, this one?
Yeah, it's
We are
okay.
we are applying the formulation and that's it. That's what we have.
Yeah, yeah, yeah.
Also, we have other stuff as well. Like okay, before jumping the next one, MAPE. This is the okay. Let me bring that one formulation as well. Yeah, this is the dividing with the original.
Mean absolute percentage error.
Yes,
Percentage.
because yeah. But I'm not gonna do that one because we already did. Everything is okay.
Okay, so you
So
just
yeah.
apply. Yeah, but what's the y in there?
Why is imagine like you are taking your real time,
Mm-hmm.
real data from the estimation, then divide yourself.
Mm,
You are taking the percentage of yourself.
I'm not
Okay.
sure.
Okay. Let's make that one. Okay. 112 pounds.
Yeah.
You sell something. Then you estimate it is going to sell 100 pounds. What is the percentage of your estimation percentage error?
12%.
Yes. Yeah, less than 12, but
I
yeah,
mean,
you are
not
near.
yeah, not exactly 12, but
Not exactly. Yeah, it makes sense now. Okay. So I think, yes. So it is calculating that one. This one.
okay, I understand that. Yeah, yeah, yeah.
So how your estimation is wrong or correct over percentage, absolute percentage.
Okay, okay, okay,
Because
okay.
absolute is here, therefore.
Yeah, yeah, yeah. Okay, yeah, yeah. I see. So basically, instead of using a value with minus, you just yeah, makes sense. To be honest, I would intuitively I would have thought that percentage is easier to understand rather than absolute value because we know that it's
Yeah.
percentage of error, so it makes more sense.
Yeah. Okay. Maybe you may wish to prefer that one, but try to all of them.
Yeah, yeah, yeah,
Try to
yeah, yeah,
see different
for sure.
between them. So okay, this is the autoregression. Let's say autoregression. This bit is a bit like difficult to explain autoregression. Maybe I should maybe write ARMA as well, or sometimes they write ARIMA. I'm not really knowledgeable at the moment about this, but I try to like learn by I'm explaining it as well.
Yeah.
So what is happening is like so between these two, whether is there correlation or not, how we
Right.
can
All right.
estimate the correlation.
Wow, that's interesting. Oh, that's actually really interesting.
Then whether these two is good correlation or not, okay. So
Yeah.
kind of like then another term is saying, you know, whether this one okay, another term is coming from here now.
Term?
Okay, I'm gonna add up here. This is T for time.
Okay.
C1 is the 58. Then if you take 1 minus, it means it means lack of the lack of the data. It means that one. Checking one previous and the next one each other. So let me write here 58, 54, 60. Same things for the first model, 55, 62. But we are not estimating at the moment because it is too early. 63, 65, 62, 62, 55. Yeah. So we are checking now this two correlation between these two correlations. So if correlation is too high, it means yeah, literally we can say the previous month can estimate the next month.
Mm. Yeah, that's good. And if the correlation is really low, then maybe
Estimation.
you can put less weight on the estimation and the
No, don't confuse the weight. Weight is the previous section. Okay,
right.
this is not the weight. What you need to do in that sense. Okay, let me go. Maybe that one linked to the one previous week. Maybe 60 is related with 58.
Right.
Maybe this is 54, 2 weeks before.
Yeah, but I just yeah, okay. I was saying I would struggle to see how correlation could happen just between two values, but I see you introduce third value now, yeah.
So this is 62. Yeah, this is 62. Then this is 65.
So
So
this is
we are so between correlation with these two, or which one is better? Okay, we don't know. Okay, we don't know at the moment. And what we do is here we make a kind of like, because correlation is minus +1 to -1. Okay, never coming other way, more than one or less than
yeah, yeah.
-1. So what we do is here we make this kind of chart. Okay, my mouse is stuck. This is +1. This is -1. Okay, this is the correlation values.
Mhm.
Okay, let's say we do for the first log, we call that one log. Okay, for
Lack?
first log. Okay, first log is that one. Second
Mhm.
log is that one. This is the first one. This is the second one. This is the third one. So we are checking whether correlation is here, here, here. Okay. In general, tendency is in sales and other stuff is high. It is going that way. I mean, like slightly going down because always we sell things same as we sell before. Okay,
Right.
last, but it might be different. Okay, you need to check because your business could be different. So so whatever we say, we make this calculation as well as these calculations. We have always statistical errors as well. So that errors are supposed to be that way. This is a 5%, okay? If it is 10%, it could be this way.
Okay.
So identically, it is going to come that way as well. So what we need to see is always we need to see these dots, red dots are underneath this scope. So then we can say it's statistically significant. Then
Okay.
if it is not statistically significant, we won't be able to say yeah.
Yeah,
I
yeah,
mean, we can't argue it is reliable. Okay.
yeah. So usually statistical significance would be around 5%. It
Yeah,
depends on
in social science we go with the 5%.
in more uh
In computer, for
analytical,
example, computer
yeah,
production, you are
would be
making
less than
some.
that.
Yeah, it should be 1%.
1%,
Maybe.
yeah.
Yeah, because computer is expensive, should be accurate.
Okay.
For medicine, for example, same.
Should be very, very accurate, yeah.
Maybe less than maybe 1 out of 1,000.
Yeah, yeah,
Should
yeah.
be.
0.1% or something, yeah. Okay.
Should be. Yeah. It's up to then these things are becoming really difficult to estimate as well in that
Yeah,
sense.
yeah.
Okay. Where is that? Your old friend is here.
A movie, yeah.
Jamomi coming. Jamomi on the way.
I had to delete Jamovi because of storage on my computer.
It's okay. You can always
Reinstall,
download.
yeah.
So I'm gonna take these things like and check the correlations are significant for these two. Obviously, I won't be able to give okay, other one. Yeah, anyway, normally we don't have specific place. I think. Is that time series here? Anything? No, I don't see. Okay, anyway, I think ANOVA has got this correlation things.
Mhm.
Description, homogeneity, maybe t-test, not t-test, ANOVA, maybe this one. If you see the correlation here somewhere, let me know.
Correlation. I I kind of forgot how it works.
Okay, there's no correlation here. Model, assumption,
Would it
homogeneity,
be,
normality.
isn't it regression?
No, regression is later. You need
Okay.
to go with regression later. Maybe this one,
Let me check.
correlation matrix.
Under, so I check online. Apparently, under the regression, you can run correlation.
Oh, right. Okay. You were correct. Yes. Okay.
Correlation.
Correlation. Yeah, I click that one here, correlation there. Then I'm gonna put this two. Then it's gonna tell me, hopefully, yeah, 0 point. It's not significant, seems.
No.
Okay.
Wait, which percentage of significance are we using? 5 or?
Mm, yeah, 5%. Yeah, should be. Yeah, this is
Yeah,
5%
this is like
confidence.
36%, right?
The P, yeah, 36. Yes. Okay, let's do the other one as well. If you weren't here, I wouldn't bother myself to test in the Jamovi this one. Okay. So when I copy this is the second lock. Okay, second lock. It means estimations is belong to the two term before. Okay, lock. It says lock.
Luck.
Um, Analyze screen regression. So I'm going to put A and C. Yeah, no, it's significant, you see?
Now
Hmm.
it's
Yes.
actually pretty good, yeah.
Yeah, this is pretty good. And you can say that they are significantly correlate with the second lock rather than first. So do you think you can offer kind of like, maybe I shouldn't say a seasonality for this sense?
Sade analytic? I see
Season.
an analytics, yeah, yeah, yeah.
Yeah.
Yeah, I think it could make sense if we had more data over like the previous years or previous
Yeah.
month, and then the
Yes.
correlation was consistent for this month, then I would guess that seasonal definitely happens.
Yeah.
Especially
Expectation.
especially I assume, I don't know if it's the case, but I assume that they also cross the data with actual market analytics from we know that I don't know they sell ice cream on the summer season. They would
Oh, yeah.
expect I guess they would expect that in some markets they can already expect the correlation before even making the calculations, isn't it?
Definitely.
But the Jamovi can is it not possible to just get that p-value on Excel directly? I mean, surely it's possible, but
Mm, maybe Excel is doing as well. Yes. Yeah. Maybe I'm wrong. I mean, I don't know. Maybe. Do you know how to? I can learn. I mean,
I have no idea how to do that.
can you just ask the things? So
Yeah,
maybe I can divert me.
I will ask.
Correlation
I will ask how to get the p-value.
or correlation in Excel. So I made this red thing above that 5% interval.
Right? Above 5% interval. That's why you decided. Um, so formula Excel provides the correlation coefficient via so there's a formula which is Correl, Correl, and then you have to give two arrays. I can send you that on I will send you
Yep.
that
Please.
uh,
From WhatsApp or from text here in the message.
team I will send you from Teams directly. Um, I wish I had not broken my OpenClaw. Otherwise, it could help us a lot.
Ah.
You
Oh,
can
it was going to help us now?
it could have, yeah. You
Oh,
can integrate it inside of Teams directly. Hakan, how do I send you images inside of Teams?
From WhatsApp probably. If you have
Alright.
WhatsApp in your laptop.
Yeah, I sent you on Teams.
Okay, I see. All right. Corel. Okay, these two. Okay. Okay, I will do. I understand, I think, but it means Corel and this is square root. Yes, one. This one versus this one. 0.44. Yes. Oh, great. Dollar. Dollar. 7.2. 7.2. Yes, same. Yeah. It was significant distribution. Is yeah, this is the T distribution. Okay.
Hakan, this AI is Gemini. It's really, really good.
Yeah. It's also making the website as well, isn't it? No.
Oh my God, Gemini is so, so good. It makes the really beautiful websites. I use it to make my own websites
Yeah.
for my business. It's really, really impressive. Okay. Uh,
Yeah, this is a challenge for me. Yeah. Okay. Okay. I will because it's I won't be able to copy this. I'm gonna ask again.
yeah, we can.
Correlation um, formulate.
It gave you a second method, Hakan. I sent it in the chat as well. If you
Okay,
try,
great.
which is a bit less technical, I think.
Have you sent here or?
You might need to go to the no, not on WhatsApp. Well, I can also send it on my WhatsApp, but the main chat on Teams. If you open the Teams app,
Yeah, I opened, but it's not here.
no
Okay, but
worries.
I seen my phone it was showing.
I'll send you on WhatsApp.
Okay, go to data tab. Data is on right. Analysis toolpack. Okay, analysis toolpack. Yeah, this is toolpack. I have that one.
Hakan, I'll just take just one minute. I'll be back.
Okay, no problem. Relation. Okay, input range to the range. Oh, column B, B, C. Hmm. Right. Oh, yes, okay. Hmm.
Okay, thank you.
Thank you for staying and yeah. Some correlation is C1. Okay, I understand now because I couldn't make sense. The number of rows is C2. Okay. I have that tool pack, but I couldn't. It's correlation here, but I couldn't make it. Maybe I need to put. Maybe I can make new, brand new one. Delete.
I thank you so much, Hakan, for taking the time to teach me. I know it's also good for you. You said to plan the teaching, but it's really interesting for me. So I appreciate you taking the time.
Yeah, thank you. Thank you very much for me as well. It's really nice to have one. And you have a good eyes. You can catch the wrongs as well. So T, ABS, then correlation value is that one. Okay. Then times square root. I'm, I I decided to make your first formulation
Yeah.
right. Okay. C2 says here C2 is the sample size, isn't it? So sample size is for this correlation 2, 4, 6, 7. Sample size 7 minus 2, close one bracket, divide bracket 1 minus bracket because I need to get the square root of it. This square root, a square of relation, then close because this is on the square one, and this close for this bracket for the big one.
Mhm.
This one bigger one, and this one bigger one. And it says put here 7 minus 2. Why it's 2? Because 2 is, we have 2 column, therefore it says 2. Highly likely. uh, why it says password?
Why does it keep asking your password, by the way?
I don't know.
It's true also earlier.
My computer is knackered.
Is this the
TV.
work computer?
No, this is my private one.
Well, I can tell you it's better than Raspberry Pi.
Okay, now I think it's 32%. 32. Let's go to Jamovi. Was it 32? First one? Yeah, 36.
Why
Next
is
one,
there?
1%.
Yeah,
1%.
it's strange.
The next one is okay. The first one is a bit difference, but it doesn't make too much difference anyway. It's over
Yeah.
5%. So I learned this calculation, but I'm not sure if I need to do it one more time. I need to, because I opened the formulation you sent me. You were really helpful. Thank you very much, by the way.
Yeah,
This
you're
one.
welcome. It's normal.
Okay, I'm gonna copy that one and paste it as well. Because I'm not a statistician, and I just follow what Jamovi tell.
Yeah, but you can use Jamovi like a pro.
Yes, we always can. You see that one and so yeah. So this is the thing what we doing
Yep.
in in things. I think I'm more or less done. Some remember I always say do some preliminary checks.
Yep.
Yeah, there are some preliminary checks for this one as well, like normality. Because when we come, okay, let me have another one. Here we go. When we estimate something, estimate, okay. That one always has got error. This is error symbol.
Okay.
So we need to check whether this error symbol or is normal, normal distributed or correlated with anything, because if it is something correlated, it means we should include some other variation. Yeah. So this is the part, like we call that one is earlier. I have this one in my screen on the right because I was working on that one.
Okay.
The one is not me because I'm not at the moment in this club, but it says white noise here. That one.
White noise.
Actually, it is saying same things what you check in your dissertation, hemoscedasticity. Do you remember that one? Hemoscedasticity.
No, to be honest, doesn't ring a bell.
Okay, talking about. Okay, then. Spread of the data stay the same over time. It doesn't suddenly become more volatile or calmer. So hemoscedasticity is that one. Check in your data because you don't want to end up you don't want to find yourself on floor, because you need to check whether that one is changed drastically or not. Yeah. I mean, in your analysis, I think you did ANOVA analysis, heteroskedasticity, something like that. Okay, you check that one. I think maybe you may remember that one. It says, but now AI made the explanation for this one. The dice always has the same chance of each number. The variability never changes. But yes, but it it says it is measuring whether that volatility or becoming too silent at any time. Okay. So the autocorrelation we check earlier, that one is the autocorrelation what we check actually. Today's value tells you nothing about tomorrow value. There is no, it means no autocorrelation. If there is no pattern, no trend, no seasonality, no momentum. Okay, so it means no autocorrelation. Every observation is independent of the previous one. We don't presume time series or our sales is separated from the last sales. We always think it's related. So therefore, we need to check correlation is accepted to once a little bit, and the first correlation always higher than the rest of them. So this is the one. Okay, name it white noise in time series. Okay, let's say this is all old data. And you offer one model. That model is like this is two. That model is y equals ax r to b is plus b, or maybe you can put something beginning of this cy c times y equals ax plus 1b. So it's kind of like you offer kind of like one formulation like this.
Okay.
This is your formulation, and you say, yeah, this is my estimation. Cool. I mean, it's gonna make it better. But when your boss is gonna ask you, or your friend will ask you, whether is there any difference between?
Yeah, I need to.
Yeah, you need to check them. Okay.
Yeah, I've seen this before. Yeah.
Yeah. So
Checking how far it is from it.
yeah, x1, x2, x3. So if that one, these are systematically, creating something. It means you need to add some new variable here, like plus dz, because something is systematically exist. It means it is there, something. So it says like here in the textbook is random noise, but it is too extensive at the moment for me as well, because I need to work on that one to explain you. But the terms are here: homoscedasticity, normality as well, normality, because we always check the normality. Do you remember normality is that
Yeah.
the
I'm not
normal
sure.
distribution?
Yeah, normal distribution. Yeah, absolutely. Yeah.
We check whether these axes are normal distributed.
Following the normal distribution, you got it.
Yeah. Because we expect that way. If it is not, we can say something is disturbing and it needs to be included, like this one. Yeah. Autocorrelation, homoscedasticity, normality. I think that one is the normality, constant mean. This is about normality, I think. Try to explain that one. Because I don't know what base is explain AI. I didn't read that one correctly. It says noise, random noise is disturbing the things. It's not like helpful.
Yeah. One of way to remove the noise, you can like just calculate and remove the outliers. Is that like one of the way?
Yeah, I think yes. Uh, Also, we have like the different models as well, because these are basic models.
Yeah.
To check. Yeah, we can check them whether they are okay or not. So what I used to do is in our first article with Işık, I use this system, heteroscedasticity, autocorrelation. In economics, we always say, I mean, not we, they say, because I'm not
You're
economist.
also part.
Yeah, I'm part of what, yeah. Okay, yeah, you can include me, yes. Like, if something is crazy, okay, here today, but it's gonna settle later on into stable. Like long term figures always is going to be unstable. It get a stable situation. We
Yeah.
always, when we are making
This is like
this,
stock markets.
yes, it is keep increasing, sometimes volatile, but it is steady. Okay.
Yeah. This is like stock markets, the noise on short-term function, but
Mhm.
long-term it's tending towards something, isn't it?
Yes. And therefore we need to check, the stationary. This is another term in time series, stationarity. So we are checking. This is one of the formula is making that calculation. I mean, I don't know how it works, but
Yeah.
I open this one.
Stationary, what does it mean?
Yeah, it means what you just said. It is in the long term
All right.
is settled down.
Yeah.
So there is one program. When I put data here on this one, this is free one for student version. So this is data. You are checking this formulation. Can you see the first difference?
I can.
Second difference? These
Yeah, I can.
these are logs. Okay.
Like
I'm
like
checking.
me.
I'm checking on the first level. The data itself.
Yeah.
If this is significant, you can say it is stationary.
Now it's not.
I know it's a bit annoying. Uh, I keep using different programs, but I know stationarity. I can generate stationarity from this program. Therefore, I'm keeping this program. I don't know how to. Maybe Excel is doing as well. Same things, maybe.
Or
I
probably.
always go and do the things, but where I learned, I don't want to learn new things. Yes. So I can share this document with you if you don't mind.
Yeah, sure.
Great.
Maybe you can share on Teams.
Yeah. Definitely. says. Okay, okay, it's uploading. Have you received?
I did. Yep. I just need to open the chat. Which I lost the window. I got the notification, but same problem as you had.
Okay, done.
Okay, got it. Yeah,
Okay.
thank you. So I'm opening the Excel. Yeah, I can see it now. Wow, great.
Yeah, Nathan, I think I am I consume all my knowledge so far.
Yeah, no, that's great. Yeah, it was really interesting.
It's a huge textbook, and I'm planning to finish that one.
So how do you do that? Do you read the textbook and then you try to like, so you're learning from the textbook and then you try to teach your students? How does it work?
Yes, yeah, this is the way I'm planning to do.
Mm,
But you know, I feel confident because I did some article about this one, and I think I can do.
yep.
It could be more overestimating. I don't know. But if they give me the job, what I'm gonna serve is this way. I'm gonna serve my students.
Yeah, I'm
Yeah.
sure you can do it. And how will they? Well, I think you can finish the recording now if you want, unless everything is recorded. I don't know.
Yes, stop recording. Yes.